Alright, today's lesson is going to focus on some key properties of parabolas. Now you look at this and it looks like there's quite a bit of information here. I'm kind of summarizing the lesson in like one slide. So I would encourage you to maybe pause this video right now and just write down in your notebook the information from this slide. Some of it's going to be review, but I would encourage you again pause and write this stuff down here, okay? And then I'll talk about it. So remember, any graph of a quadratic is going to be a parabola. General quadratic can be modeled by this equation, and again this should look really familiar. Y equals ax squared plus bx plus c. Remember, a, b, c are just going to be numbers when we see that equation. The axis of symmetry divides that parabola in half, and that line goes right through the vertex of the parabola. Now, I don't think we've seen this before, okay, so definitely want to make note of this. This formula, x equals negative b over 2a, can be used to find the axis of symmetry. Note that will also give us the x value of our vertex because it passes right through the vertex. So negative b over 2a, that's an important formula for you to make note of. Again, that's if it were in this general form, ax squared plus bx plus c. Now, once we have that x value of the vertex, if we plug that x back into the equation, it's going to tell us what the y value is. So then we would have the overall vertex. Now, some basic properties kind of refresh our memory. We talked about transformations in a previous unit. If that value out front, if that a value is negative, remember that's going to flip it upside down. It's a reflection in the x-axis, so it's going to open downward. And if the absolute value of that a value is greater than 1, so it's a 2, a 3, a 4, whatever, then it's going to skinny that parabola up. We call that a vertical stretch, so it's going to be more skinny than normal. And if it's a fraction, like 1/2, 1/3, 1/4, then it's going to widen that graph out. We call that a vertical shrink. Okay, those are really the big ideas we're going to explore today. Let's go look at a couple examples together, types of problems you're going to run into. So, which graph represents this function? Okay, x squared minus 2x minus 3. Well, one thing you could do, by the way, is you could always just go to Desmos.com and graph this and see which one matches. Not a bad strategy, by the way. But I want to show you kind of how we can figure this out. Now, first of all, notice this is a positive number in front. So it's not going to open upside down, so I can automatically cross out that middle one. So here's where this formula, x equals negative b over 2a, can be useful to us. So let's use that. So negative b, well, b is negative 2, right? Again, a, b, c. So b is negative 2. So if I do negative 2 over 2 times a is just a 1 in this case. Well, of course, that would be 2 over 2, which is 1. So I know that the axis of symmetry is 1. Well, there it is, isn't it? So it's got to be this function. This one is over at negative 1, so it doesn't work. So that's how I could identify pretty easily using this negative b over 2a, okay? How about this? What if we want to find the minimum or maximum value of a quadratic? And this is especially useful. There's a lot of real-world models where a quadratic is going to model something, whether it's cells or seasons or whatever. And so we're interested, what's the minimum? What's the maximum? Well, let's talk about how to do that. Just find the y value of the vertex, right? We can use that negative b over 2a, and then we're going to plug it back in and get the y value. So let's do that. So for this equation, what's the minimum value? It's going to have a minimum, by the way, because this is positive. So this parabola is going to open upward, and so it's going to have a minimum down here. So negative b over 2a, remember that gives me the x value of its vertex. So here's my b, it's 12, so negative 12 over 2 times 3, so negative 12 over 6, so negative 2 is the x value of the vertex. So I want to find the y value. To do that, I'm going to plug negative 2 back in for x and see what the y value is. So let's do that. So y equals 3 times negative 2 squared plus 12 times negative 2 minus 4. So let's see, negative 2 squared is 4. 3 times 4 is 12. Minus 24, right? 12 times negative 2 minus 4. 12 minus 24 is negative 12. Minus 4 is negative 16. So y equals negative 16. That right there is the minimum value. Okay. By the way, the vertex we just found, if we want to go, is negative 2, negative 16. That's really what we just found out. We identified the vertex, which gives us the minimum value. Let me show you how you could check that real quick. Okay. Well, couldn't I just go graph that equation on Desmos? I've already done that. So I typed it in here. I've got that little thing in the way there. Let's get rid of that. So I just typed it in, graphed it. You might have to adjust your window a little bit. The bottom of it was probably off the screen. It was like that when I first graphed it. So you can just drag it around, move it around. Click on the graph, and there's a key value. Notice negative 2, negative 16. It gives me that key value, the minimum, just like that. So, not a bad tool to go use. I'd like you to know how to find it algebraically, but also, again, keep encouraging Desmos, awesome tool. I hope you'll utilize it. Makes your life simpler, okay? Let's go and do this one. Now, I'd encourage you, maybe pause the video. I guess you could go use Desmos, but I'd encourage you algebraically, like that one above. Let's see how we could do it. So x is going to be negative b over 2a. So negative 15 over 2 times negative 3 in this case. So we've got 15 sixths, which is what? If we take a 5 out of both, or a 3 out of both of those, we get 5 halves. So my x value is 5 halves. So not quite as nice for this one, but that's okay. Right, now we go plug it back in. So y equals negative 3 times 5 halves squared minus 15 times 5 halves plus 9. Okay? And now, of course, this is going to be a good problem just to maybe go plug in your calculator or use Desmos.com as a calculator. But let's run it through. Let's see what we get. So I'm going to run out of room here. Negative 3 times 25 fourths minus 15 times 5, what's that, 75? So 75 halves plus 9 equals, in fact, I would just plug this in a calculator, okay? So let me bring up a calculator. In fact, I'll bring up Desmos and just show you as a calculating tool how nice it can be. Okay, so from the very same window, what if I just wanted to type this in? So negative 3 times 25 fourths. Whoops, I don't need that parenthesis down there. And notice it's giving me a value down here, just a running total, so it's also a calculator. Minus 75 halves and plus 9. And it looks like negative 47.25. So, back down here, negative 47.25 is the maximum value there. That doesn't feel right though. What is the maximum value? Did I do something wrong? Negative 3, 5 halves squared, minus 15 and 5 halves plus 9, minus. Alright, quick check on my math. I realized what I did wrong, and this is good for you. I make a lot of mistakes as well. It's okay. So here's, can you see what I did? So in this equation, I went ahead and this became a positive 15 up here, but it was actually a negative down here. So this should be negative 5 halves. So when I plug it into everything, this is going to end up being a positive value. Because minus 15 times negative. So this will be positive. This would still become positive. So when I plug that in my calculator, let me bring Desmos back up. And let's go fix that. So I would actually have a positive value right there. And then 27.75 is going to be my maximum value. Okay, so 27.75. Hey, there you go. Not too bad. Sorry for the little mistake, but again, you can see that I'm human as well. Okay, one more example I want to show you. Again, pretty straightforward, I hope. Which function describes the graph? Well, now that it's got three equations, again, worst case, I guess you could go graph each of these, see which one matches, right? And that's not a bad strategy. But let me show you something we could do. Let's look at, we can see the vertex here, can't we? It's the point 2, -5. So probably just as quick, let's plug that 2 in for x and see which equation gives -5. So first one, 4 plus 8, 12 minus 1, well, it's definitely not that one. 4 minus 8, so that'd be -4 minus 1. Hey, that equals -5. I like B. Let's check C real quick though. 4 minus 8, that'd be -4, plus 5, that'd be +1. So notice it is going to be B there. Okay, so again, I hope that'll go through. Those are the big things you're going to be looking for, working through as you go through this lesson.